Good afternoon, everyone. Thanks for coming to our session. My name is Umesh Shankar. I'm a principal engineer at Google, based in our New York office. I'm the technical lead for Access Transparency.
And my name is Joseph Valente. I'm a product manager, also based in our New York office, and I'm the PM for Access Transparency. So it takes a tremendous amount of trust to put your data on the public cloud. And it's very difficult to gain that trust when you don't have full visibility over what's happening to your data. And so that's why today we're really excited to talk about Access Transparency. It's a new product only available on GCP, and it gives you full visibility over what happens to your data on the cloud. So we know that companies in every industry are increasingly using software and data to change the way that they do business. This isn't just true for companies in the technology and finance and other industries that have used software for a very long time. It's also true for businesses in manufacturing, in logistics, and even in mining, where we're seeing lots of companies that previously never even hired a software engineer now running multiple teams at scale, deploying software to production daily. And the public cloud is very important in these situations because it gives you the flexibility, it gives you the ability to manage your costs, and it also gives you the availability of technology that you need in order to facilitate that shift. Now, at Google, we know a lot about building great software teams. Over the last few years, we've built 7 separate businesses, each with over 1 billion users on them. And in order to do this, we needed to build a phenomenal internal cloud. The internal cloud we built out is the same one that we make available to you through Google Cloud Platform. And it combines incredible enterprise-grade reliability with super-fast compute and storage, as well as security and compliance. And in order to do this, we had to completely reinvent the way that the data center works from the ground up. And we've done such an incredible job of it that now people, instead of going and checking whether their internet works, just go to google.com because they assume that Google will be up. And we're really, really happy to be able to offer this to you. There's a saying as well that says that anyone who's serious about making software makes their own hardware as well. And at Google, we're obviously very serious about making software, which is why we make our own hardware. And that's what you can see on the screen right now. This is one of our custom Tensor processing unit chips. It's completely designed in-house by Google, and it's available to you to use on Google Cloud Platform. Why did we build this chip? Because we wanted to take machine learning to the next level. We wanted to completely optimize the experience of running machine learning computations in a data center. And this chip is 15 to 30 times faster than a conventional processor for machine learning applications. Think about being 7 years into the future in terms of what you're able to do with your computer. That's what we can do with this chip. Now, how do we use this internally at Google? We use machine learning at Google to actually invest in how we cool our own data centers. Data center cooling is a really, really complicated thing. You need to take into account the weather outside, the heat of the data center. You need to take into account the pumps and the pipes and the ducts. And it's a really complicated equation for a human to solve. So we set up a machine learning classifier and we asked it to optimize all the variables in the equation. And we were able to cut the costs of cooling our data centers by 40%. It was a drop that was so big that we thought there was an error in the calculation. But we're excited that you guys will also be able to do this in your own businesses using things like the TPU only on Google Cloud. But being on the cloud means having people to run the cloud. People who are going to help you achieve that level of reliability, achieve that level of usability, and achieve that level of security. And very specifically, in the case of Google Cloud Platform, it's these people. Not these specific 3 people, because we have slightly more than that running people working on Google Cloud today, but Google Cloud software engineers is what I meant to say. And these people are the people who are responsible for making sure that your service is always reliable, it's always up and running when you need it. And part of working with a new group of software engineers is developing a new relationship of trust. So in your on-prem environment, you probably had vendors, you had employees, you had people who were working to make sure that your systems were reliable. And you developed a relationship of trust with these people over a long period of time. Moving to the public cloud is no different. It just involves you entering into a new relationship of trust with a new group of people. And that's what we hope to give you a bit more information about in today's talk. So far I've spoken about cloud migration. I've talked about how important it is for changing the way people do business, the flexibility, the reliability, the cost management. And I've spoken about big data and machine learning, how exciting that is and how many opportunities that's going to open up for all of us in every business, in every industry. And I've also started to talk a little bit about security, compliance, and trust. Now, the challenge for you today is that these three big themes can't be tackled independently. Every business is trying to do all of these things at the same time, and that's very, very difficult in a changing environment. And it really, really helps to have a cloud provider that you can trust that they're investing in security and compliance to bring you up to speed at the rate you need. And that's going to be the focus of today's presentation. So before we can enjoy all these incredible benefits of being on the cloud, we need to get a few things right. Security. Am I secure in the cloud? A recent survey by HighTrust of cloud buyers globally found that the top 2 fears of people purchasing cloud were malicious or accidental exposure of workload data and uncontrolled or unmonitored access by admins. I want you to think about those 2 things because we're going to come back and touch on them later in this presentation. Compliance. Can I meet my compliance obligations? Now, this is not just about compliance with external policies that you may have to comply with or external certifications. It's also about compliance with your own internal policies and being able to have visibility and certainty that you can certify that those things have been abided by. And finally, trust. Can I trust my cloud provider? This is related to security and compliance, but it's slightly different. This is more of an emotional thing. Is the person that I'm in business with along with me for the journey to make me successful? So these are the 3 needs that we need in order to move on to the cloud. But the way that we see it at Google is that in order to meet these 3 needs, we need 3 foundational pillars in place: technology, operations, and accountability. And to talk to you more about these three pillars, I'm going to invite Umesh.
Thanks, Joe. First thing we're going to talk about is technology. If you don't have a secure technology stack from the ground up, nothing else really matters. No amount of operations, no amount of accountability is going to save you if your data is not fundamentally safe. We look at this problem as a series of layers, right? You have your hardware at the bottom, you have it all the way up through your application layer at the top, the software that's actually running on the platform. And we've actually invested in every one of these layers to make it secure, to harden it, and to address all those 3 aspects that Joe talked about. So let's start at the bottom. We're going to dive into each one in turn. It used to be the case, and by and large still is true, that if you order a piece of hardware, you get it as the manufacturer intended it. Unfortunately, it's not always true. And there have been real attacks in the wild where the supply chain has been compromised. So you're a company, you order a piece of hardware, maybe a network card as shown in this picture, and it shows up with malware already installed on the card. Maybe the firmware has already been compromised because someone inserted themselves in the supply chain. This is a real thing that happens, and it's something that we actually very actively worry about at Google. We've taken steps to directly address this problem. We've actually developed a custom chip, which we call Titan, which gives us a hardware root of trust for both machines and peripherals. So on this network card, which is the kind of thing you might find in any of our machines in our production network, there's actually this little Titan chip on that card today. And what that does is allows us to verify the integrity of all the firmware and other components that are on the card. So when it comes online, we know it hasn't been tampered with relative to where it started. So as you might imagine, we have a lot of machines at Google. And you can see them represented by these little boxes. Unfortunately, I'm not allowed to say exactly how many machines we have. I'm allowed to give you a range. So it's somewhere between 100 and 10 billion. That I can tell you. And each one of those machines can be in a different state, right? So some might have just been booted up. Some might be running some software. Some might have been online for a while and are in an older version of software. How do you kind of manage these things and make sure that things are in a good state over time? Again, here, if we look at what it takes to start up a machine, you turn it on, you load the BIOS, that loads the bootloader and so forth. We've actually taken steps at each stage of this process to harden each thing. So we use Titan at power on time to make sure that the next thing is loaded correctly. We do our own custom BIOS where we've actually hardened it and made sure there's no extraneous software. We've done the same thing for the bootloader. We've done the same thing for the Linux kernel. So we actually pare away all the parts of the kernel we don't actually really need to run things in our data centers. And we actively contribute security improvements to the kernel itself. And finally, the OS image, the software that runs as a base image on the platform, is something that's very carefully managed and curated. At the same time, we keep a cryptographic trusted boot chain as each stage is loaded. So we start from Titan at the bottom, we get the BIOS next, and as the BIOS loads the bootloader and the bootloader starts the kernel, each one signs the next thing. And what's so important about this is when the process is complete, we know that each step was genuine. No one could have changed or inserted something along the way. A really fundamental concept in the way that we think about security is that of identity. To run a cloud, to run a data center, you need services, you need machines, and you need people. And we assign each one of these things an identity in our system. So we just saw all the steps that a machine has to go through in order to boot. Well, what we do is we only assign a machine an identity at the end of that process. And because virtually everything works by one thing talking to another thing over some communications channel, if you don't have that identity, you don't get to talk to anything else. So only authentic machines even get to talk to anything. Similarly, we apply the same philosophy to services and to people. For people to get an identity, they have to pass both a two-factor authentication check, which involves a secure hardware second factor, and they have to be coming from a trusted managed device. And if they don't pass those things, they don't get an identity, which means they can't talk to machines and they can't talk to services, which effectively means they can't do anything interesting, which is as it should be. We actually, as it turns out, do the same thing for services as well, and we're going to come back to that in a couple minutes. You'll see how we have the same notion of identity for a service and how we make that notion strong. So we talked about how communication is constant. Each of these kinds of things are talking to the other during the normal operation of a data center. And each link is strongly authenticated. So when we say identity, we actually mean giving something a cryptographic certificate that contains its identity. And so whenever you have a link where one thing's talking to another, one party always has a strong idea of who the other party is. And it can use that to make decisions about whether it's what it expected, what it's allowed to do, and so forth. All right, so we've got our data center up and running. We've given identities to things. They're communicating. Things are starting to work. We're getting some data in the door. How do we manage that data? Well, one of the most basic and important things we can do is make sure that data stays encrypted, both in transit and at rest. All the data coming from you as customers to Google is protected with TLS. So it's encrypted in transit there. And then within the data center and between data centers, we actually use a combination of hardware and software encryption to make sure it stays encrypted across network links. When we're about to store the data, in other words, to repose the data, we actually take it and we encrypt it in chunks with different encryption keys. And this kind of ties back to what we looked at a moment ago. Then the question becomes, who gets to decrypt the data? Who gets to have the key? And so our highly secure key management system will only hand keys for, let's say, cloud bigtable data to the service that manages cloud bigtable. And it knows it's that service because it has a very specific identity. The cloud bigtable service's identity is distinct from that of all the other software. And that's how we make sure that data only flows in the appropriate direction. So I said a minute ago that we have this notion of identity for services as well. And this is really critical to the way that our whole system functions. So let's come back to our example of cloud big table data. You create a cloud big table instance. We store that somewhere. Access to that data in storage is tightly guarded by an access control list. And we'll list all the machines, people, services, anything that's allowed to access it must appear there, or the access is not allowed. So let's say we have the system that actually serves cloud big table data back to you as the user. That needs to appear here. But what does it mean? How do we know what things ought to be in that list? What distinguishes the cloud big table serving code from any other code? The answer is we have a system called binary authorization, which is quite novel. And actually, as of today, it's something that you can start to play with on Kubernetes on cloud. And what it does is it lets us tie those production service identities to specific pieces of code and processes by which that code is managed and deployed. So in our particular example, we would say we only want to put the cloud big table service identity on the ACL if it was built from the particular build target in our source repository that corresponds to the cloud big table serving system. And we want to know that all that code that went in there was reviewed by a second person. So one engineer couldn't make a mistake and screw the whole thing up. We want to make sure that code was built by our trusted build system. We want to make sure that it was released in accordance with our mandated release process. Binary authorization lets us do all these things. And in fact, we do them. So for something to get access to that user data, it has to pass all these steps. It has to be code that was purpose-built to do this one thing. It has to have been reviewed. It has to have been built. It has to have been deployed in a proper fashion. And finally, it has to present that strong cryptographic identity. This is the kind of thing that gives us confidence in the overall operation of the system. So I've given you actually a pretty brief overview of our tech stack. If you're interested to learn more and you want to get more details and information, there's actually a fairly detailed technical white paper on our site. If you go to cloud.google.com/security, it's called the Security Infrastructure White Paper. So I encourage anyone who's interested in learning more to take a look. All right, so that's the technology part. But as Joe said earlier, you can't run an entire cloud just with technology. You need to have operations. You need people to improve the service, to maintain the service, to provide support. And our thinking is that defensive controls start in the data center. That's literally where the data is. So you have to protect it. And the first line of defense is physical security, right? We actually have multiple layers of defense. We actually have armed guards. We have retina scanning. We have fingerprint scanning. And I know because I've actually been to a data center floor, and let me tell you, it is very hard to get onto that floor if you're not supposed to be there, especially past those laser beams. We have a strict access management system. And what that does is it says these specific kinds of people and these specific job roles are allowed onto the floor at specific times for a specific reason. Right? So again, it's difficult to get onto the floor to even be near the machines where the data lives unless you have a very good reason to be there and we know what you're doing. And finally, we retrospectively look at who in fact was out there, why they were there, and we audit that to make sure that everything was appropriate.
Did you have to get past the laser beams to get on the floor as well? Or
I did. I studied contortionism for about 6 months, but if you've seen the movie Mr. and Mrs. Smith, it was a lot like that.
Okay, cool.
Yeah. So we said that we need people to administer our cloud, right? And that means that those people themselves can become targets, right? If I'm an attacker, if I want to gain access to Google's data, how am I going to do it? Well, I might go after someone who works at Google, right? So to protect our employees, we use those two techniques I mentioned before. We have phishing-resistant hardware authentication in the form of security keys, which is something we recommend that everybody use. And it's something which, on cloud, you can actually mandate that all your employees use as well. And we mandate the use of managed access devices. So you can't just pick up a random laptop and start debugging Google Cloud software. You have to come from a specific device that's been provisioned by Google and managed to be in a good state. Okay, so you're a person at Google. You need to do some support work or administrative work. We still want to make sure that only the right people have access to things and they're only doing things for the right reason. So here too, we have role-based access controls. If you don't work on Cloud Bigtable in a support role, you're not going to ever have access to Cloud Bigtable resources. Our support tools are purpose-built. So if you're working support, the only way for you to gain access to, say, metadata about a Bigtable is to use this support tool. And the support tool will require you to say why you're doing something. So if you can't produce the specific customer support ticket, as an example, that is the thing that you're following up on to access that specific resource, you're not going to get access. And finally, again, we employ auditing very extensively. It's a good way for us to make sure that people are using their access appropriately all the time. So let's come back to that question that Joe raised early on. Am I secure in the cloud? I mean, I can't answer that question for you, but I can say, and hopefully you have a sense now, that we have made an enormous investment in security. We have, I think, over 900 people working on security and privacy alone. And the only way that we're able to make this kind of an investment is because we operate at such a large scale. It actually makes financial sense for us to do this. We have so much at stake, and we can amortize that cost over a very large number of machines. Now, this is something that customers can do on their own, in part, but it's very expensive to do that. So we actually think that for most customers, they're going to end up having the same or better security as they move to a public cloud by taking advantage of these kind of sophisticated features that we've built. So that actually brings us to pillar number 3, accountability. It's well and good for me to talk to you about our technology, for me to talk to you about our operations, for us to publish white papers. I think these are actually all very important things. We're trying to be as open and transparent as we can about how we run our cloud, so you can have that as a basis for trust. But we think it's really important, too, to give you direct accountability. What is Google actually doing? Why are they doing it? And the reason we think that's so important is we have to hold ourselves accountable. We understand why this is so important. When you run a system like Gmail, you worry about accidental exposure of data. You worry about unmonitored access by admins. This is something that we do all the time. And the way we hold ourselves accountable, beyond all those access controls, which I mentioned, is we have these robust internal logs. We collect detailed logs of whenever people at Google do things, we funnel them into a central location, and we apply very sophisticated techniques to try to detect if anything was being done inappropriately. If we didn't have those kind of controls, we couldn't feel comfortable running those kinds of services and feeling like they were actually secure. So it's a fair question as a customer to say, all right, well, you want me to trust you to run my business on Google Cloud, but I don't have access to those same internal logs that you have. How am I supposed to feel comfortable? Well, it's exactly to answer that question that I'm really excited to announce Access Transparency. It's a new product offering on GCP. It's something that you're not going to find on any other cloud. And the point of it is to give you meaningful oversight of your cloud provider. We're going to give you near real-time logs when a person at Google accesses your content. We think this is a really important step in establishing trust with you, the customer, and giving you a basis on which you can build a secure business in the cloud. I think the best way to understand the concept behind Access Transparency is to look at an example. By far, the most common reason anyone at Google would ever have to access customer content is for support. It's when we're asked to do so. So let's look at an example. This is the kind of thing that certainly happens. A customer is a user of our Google Cloud Storage API. They try to read one of the objects in a bucket, and the data looks corrupted, and they're not able to figure out what was going on. So they call support. Now, that action by the customer admin will generate a cloud audit log. So when we talk about accountability, there's layers of accountability. So as a customer, you want to keep tabs on what your own admins are doing. And cloud audit logging lets you do that. You could see that someone was trying to read this particular object. So now let's look at the next level. They contacted Google support. And so the support person goes in. They're not able to access the content of the object because that's just not allowed by our policy in general. But they are able to access things like the access control list, because sometimes maybe the problem is there, or maybe it's with other metadata, and they can figure it out without having to go deeper. But in this case, everything looks fine. They had to say why they did it. It was to handle this particular customer support ticket, 12345. And it all looks fine, and they're going to have to escalate to engineering. Now, before access transparency, this is what you would get to see as a customer when that access occurred. Pretty much a gray box, right? That's not very satisfying, right? With access transparency, it looks very different. You're going to get a log in near real time. So we're talking minutes, not days, of what specific thing was accessed. And you can see here, it's the particular object that was accessed. And at the end, you could see it was just the ACL, not the content of the object itself. You get to see what type of action was performed, and you get to see the reason for that access, right? Because the point of this is to say, yes, I can account for each thing that occurred. This makes sense to me. I understand why it happened. So let's go to the next level, right? We couldn't resolve the problem with support. We had to get engineering involved. And engineering has access to lower level debugging tools than support typically does, right? So they can actually go into the underlying systems where the things live. They can use the internal APIs to try to pull more data to figure out what's going on. All right, so in this case, again, the engineer has to say a justification. So they're doing it for this reason, this particular ticket number. And they're able to get the data and say, OK, I see what happened. The data had a different encoding than the one that you thought, and that's why the data appeared to be corrupted. We're able to recover, and so everything's good. I'll notify the customer. Great. Importantly, you're going to get another log when this happens. And this time, you can actually see that the content of the object was accessed, right? That's the level of granularity and transparency we think is really important for us to offer. I'd like to spend just one more minute talking about what I like to call deep transparency versus shallow transparency. So I mentioned that support accounts for the vast majority of accesses, right? That support requested by the customer is, I don't know the exact figures, but it's like 80, 90%, something like that. And so that seems like, oh, it's not that hard. We have a purpose-built support tool. Let's go instrument the tool. We'll get some logs, and we'll send them over to the customer. No big deal, right? And that is definitely way better than nothing, right? It turns out actually not to be that easy in the end, but you could do it. We decided to go beyond that. We wanted to say, OK, even though we could give you 80% of the logs for 10% of the effort, that doesn't really fulfill the point of this feature. The point of this feature is to tell you as much as possible about every time that someone at Google accessed your content. And so we wanted to get those deeper access points, those internal APIs, those low-level general-purpose storage systems to be part of this solution too. Now, it turns out there's way more code. There are a lot more systems there than in our support system, right? It's an order of magnitude more stuff, maybe even more. And it only gives us 10%, 5% of the logs, something like that. But it felt like the right thing to do. And that's the kind of thing that we're hoping to do going forward and bring it to all of GCP for you. OK, with that, I'm going to hand it back over to Joe to show you a demo of the system in action.
Thanks, Umesh. OK, so let's take a look at how access transparency would actually work in real life. So let's slow this down a little bit so it's easier for everyone here to see. I'm going to slow it down to half speed. Ooh, I don't want to do that. And so I'm going to go ahead and I'm going to open up a bucket, and I'm going to try and access a file, and I get this error. Permission denied on cloud KMS key. So that's not good. I'm going to go and contact support and see if they can help me out. So this is not exactly what the support person sees, but it's roundabout exactly how the experience works. Support person inserts this justification. It says case number 202123. Now try and remember that case number, because it's going to come back later. I'm not testing you. So they insert that justification, and it's checked. It says, OK, this person has that ticket open. I'm going to give them access. And they actually end up saying to you, there was this issue, and you fix it, and the data is showing up fine. So that's great. So you're going to say, OK, I fixed my issue. Let me go to the logging panel and see what logs showed up. And now you can see that in the logging panel, there's access transparency logs available because you contacted support. So we can go ahead and bring those logs up. And I'm going to expand this panel because I want to see a little bit more detail about what's inside these logs. I'm going to pick this log here, go and take a closer look. And there it is. I've got information about exactly what happened. And most importantly here, I've got the reason. So there's that case number again, 202123. So the full sort of audit pathway showing me everything. Best of all, it works with all my features in Stackdriver logging. So I can set up metrics, I can set up alerting, I can get it to send me an email. And we have another session on this tomorrow morning, Sec 211 at 9 a.m. if you want to learn more about how exactly this can be accomplished. But for now, the only important thing to know is it works just like any other log on Stackdriver. So that was a little bit hard to see. So maybe let's jump out of this. And let's take a look at, let's maybe maximize that. Let's take a look at this log in a little bit more detail. So I want to zoom in to the top part of our access transparency log and just talk through the information that's contained inside it. So the first line there is type, and you can clearly see that it says transparency log. Why is that useful? If we want to go ahead and set up alerts or monitoring on these particular types of logs, if we want to go and fire off an email to an auditor that says, please check exactly what happened every time we see one of these things, we can use this field to match so we can see that it's a transparency log. The second section gives a bit more information about the Google employee who made the access. So you can clearly see here that we've got the principal office country that the person is typically located in. We also have the principal physical location country. So that is a special field that is going to tell you exactly where the person making the access was at the time that the access was made. We've got some special technology that allows us to be able to make that determination. And then it also tells us the employing entity of the Googler. So it tells us here that that Google employee works for the Google LLC. That's our American entity. And this might be useful for you if you have specific sort of governance, risk, and compliance needs for this particular information. So the second part of the log. This gives a bit more information about exactly what was accessed. So here you can see cloud storage. There was a read executed on it. And the resource name was this particular bucket /ACL, which means access control list. So I can identify that the person in question didn't look at the content. They were looking at the access control list of this object. And finally, reason. So I can see here that the reason is given. It's clearly specified what the case number is. And I can go ahead and pull that case number up and perform an audit against it to see if it's what I expected. If I opened up a ticket that said, please, investigate why I can't access my cloud storage, and then, I had a bunch of all these logs going on and on and on and on for days, I might be like, why did that happen? So that gives you that audit trail that is able to connect everything together. You'll notice that there's also another field called type. So the type specifies that it is a customer-initiated support access. And as Umesh mentioned, the absolute vast majority of all the accesses are customer-initiated. But there are a few cases in which they may not be. In our documentation, which you can find online, we talk a little bit more in detail about exactly why we might otherwise access your data. So I spoke about customer-initiated support. You contact us, you say, hey, I need some help with something. That's the most common one. There's also Google-initiated service. Now, this is by far our second most common one, and it's where there's a bug or an outage or some issue where we detect that there's a problem and we need to go and fix it. Then there's third-party data request, and that's to do with sort of things like court-ordered accesses or legal accesses. And finally, there's Google-initiated review, and that's to do with things like abuse or security reviews. And I note that you may have custom terms that allow you to opt out of, of some of those particular review cases. I'm not going to go into detail and read all of these. I'd encourage you to head to our documentation to learn more. But I just wanted to highlight that if one of these 4 reasons isn't present, then the data will never be accessed. So, access transparency, what are the key features? What does it cover? Think about it as covering all the data you give us. So, unless it's a public resource identifier, like a GCS bucket name, we will give you an access transparency log when it gets accessed. And that's important because even something as small as the name of a VM or a label that you've attached to a VM, we're going to treat that like it's your customer data. And we're going to give you a log of it whenever it's accessed. And we did that because we didn't want to make value judgments about what it is that you find to be important or not important. We just want to give you as much transparency as we can over your content and what's happening to it on the cloud. Timeliness. You're going to get these logs in near real time. As Umesh said, it's minutes, not days. Availability, you can get it through Stackdriver logging, as we saw, and you can also get it through our cloud logging APIs and through a new offering from SAP called Data Custodian. These logs have audit-grade protections. So similar to your audit logs, you can't delete them unless you delete the project or the organization. That gives you that extra protection that a bad actor hasn't gone and removed records of what's happened. And retention, we hold them for free for 13 months. Now, some additional important details are that access transparency logs cover human accesses through support and debugging pathways. So in these cases, you'll get your real-time logs. Accesses that are made pursuant to legal investigations will typically surface in near real time. However, there may be cases where we're prohibited by law from surfacing those and they won't show up. Then there's system access. And these are things like indexing jobs, but they could be other jobs that run in our system. As Umesh explained before, we have this comprehensive system of binary authorization that verifies that the code that's touching this data in Bigtable comes from the Bigtable service. And because of those controls, we don't generate access transparency logs in those cases because we have binary authorization in place. And then finally, accesses to very low-level storage systems. These are extremely rare. Haven't seen one yet, but these are not real-time at present. There's a human in the loop at the moment. We will have real-time availability, though, in Q4. So you may be asking at this point, what's new? We've already detailed the fact that we don't access your data for reasons other than necessary to provide you your service in our terms of service. And what access transparency just does is give you another layer of visibility over that commitment. And it's part of a long list of transparency commitments we've been making at Google over many years. These include our tech white papers that you can go ahead and read to learn about how our platform works, our compliance certifications. We have a transparency report we've been publishing for over a decade. We were the first to start doing this, and that details everything about government and legal actions. Logs of your own admins on your service through cloud audit logging. And now finally, logs of Google admins through access transparency. Access transparency will be in general availability coming very soon. It'll be available for Compute Engine, Persistent Disk, Cloud Storage, App Engine, Cloud IAM, and KMS. It's available to Platinum and Gold customers only, or your equivalents in RoleBased support, and you can enable it today on the GCP website. Just go to google.com and search Access Transparency, and it should come up first, I hope. So thanks very much. To find out more, you can head to our website. And I'm now going to invite Liz Vasquez, the head of cloud security at HSBC, on stage to talk a couple of questions about how HSBC is using access transparency. Thanks. Sorry? Yeah, sure. Okay. Thanks for joining us, Liz.
Thanks, Liz.
So Liz, we heard a little bit yesterday in the keynote about how HSBC is moving a lot of your big data stuff and many other applications onto Google Cloud Platform. But as a big part of that, transparency was important in making that move. So can you talk to us about why access transparency was so important for you?
Right. To that point, my job is cloud security. So as my company is moving our data to Google, I'm the one that needs to look at what are all the controls we have in place. So we're looking at all the type of attack vectors, attack paths that we have. Google is providing us tons of access controls at network layers, access controls from our admins. As you said, all the cloud audit logging we had. But there was a space where that's where the trust comes in. And the question kept coming up where, well, what if our data is accessed by someone that's not within our control? So HSBC can control or is looking at all the actions of our employees, right? We are limiting the roles, we're limiting what people can and cannot do, what buckets they can access. So this was the last area of trust for us is, well, what if our buckets, which have this highly private and restricted data, are accessed by Google? And then the question comes up, well, don't you trust them, right? This is Google after all. And yes, we do trust them, but that's where we always say in security is trust but verify, right? So access transparency is really helping us to be able to tell the auditors, listen, this is why we're going to the cloud. These are all the steps we are doing. And even when we're calling Google for support, even when it's them legitimately touching our buckets for something that we've requested, we have a way of verifying that. So we are alerted when we get access transparency log access so that we can say, yep, we see that Google accessed our bucket, which bucket it was, and which action was taken. So I want to know that it was a read action. I want to know which bucket they actually read. And I want to know that it was based on a support ticket from us. So that's really important for us.
Great. And I think you've already sort of started touching on a little bit of this, but I just wanted to know a bit more about how you've got that sort of alerting system set up on your side. So you're saying it's alerts that are coming now from the logs. So
because thank God you guys thought about that and already set it up with stack driver logging. So we have stack driver logging that's fitting into our SIEM. And I just noticed yesterday that because we've just started playing with Security Command Center, that you're also bubbling that up there. So we also have more plans of furthering and using Security Command Center, both within several of our teams. Obviously, the SIEM has use cases where we can send that to our SOC. But yeah, for me, it's just important. It's like we have all the options. So
Yep.
we can direct it to our SIEM, have use cases there, or if someone actually just wants to use Security Command Center, which we're starting to figure out which people we want to give access to that as well, just so that everybody has visibility that it's also showing there, which is great.
Awesome.